In this lesson, we're going to be looking at modeling with expressions. We're going to be looking at algebraic expressions and what they contain and how to write them. So first is a vocabulary lesson. So if you're taking notes here, we're just going to learn some vocabulary. In the first one, an expression is a mathematical phrase that includes operations, numbers, and/or variables. If it does not contain variables, it's going to be a numerical expression. If it contains variables, it's going to be an algebraic expression. Here's an example of one. Notice it contains operational signs. We have multiplication here, addition here, multiplication here, subtraction here, and multiplication here. So it contains operation signs. It contains numbers, 8, 2, and -7. And this one contains variables, p, q, and r. So this is an algebraic expression. If it did not have variables, it would be a numerical expression. So that is an algebraic expression. Next one, the terms of an expression are the parts that are being added, that could say added or subtracted. So let's look at that same expression. If you look for the plus and the minus signs, here's a plus sign, here's a negative sign, a minus sign. So the terms are that's what separates them. So basically in this one we have three terms. We have the term 8p, we have the term a positive 2q, and we have the term -7r. Always look at the sign that's in front of them as well. So three terms in that algebraic expression. 1, 2, 3. Next one, a coefficient is the numerical factor of a variable term. So first of all, the term has to have a variable. That's what it means by variable term. So if you look at this same algebraic expression, we have three terms and they all have variables. We have the variable q, p, and r. So the coefficient is the number in front of that. So in this expression we have three coefficients. We have 8, 2, and a -7. I'll erase that stuff so that my PowerPoint can 2 and -7. And the last one, a numerical expression are the ones that contain only numbers, and an algebraic expression are the ones that contain at least one variable. But they're both expressions. Okay, so now we're going to be looking at algebraic expressions and determining the terms and the coefficients of each. So first we have an algebraic expression here. How many terms does it have? Well, if you look at the plus and the minus signs, let me use a different color here, we'll see that there are three terms. 1, 2, 3. So to list them, we literally just write those down with a comma between them. We say that 6b is a term, +3 is a term, and a -8y is a term. For the coefficients, remember that the term has to have a variable. So two of these terms have variables. So the number in front would be the coefficient. So we just write the numbers that are in front of the coefficients. So that would be 6 and -8. 3 is not a coefficient because there is not a variable. Without a variable, you do not have a coefficient. That's actually called a constant. Here's your next one on your notes. If you look at this algebraic expression, how many terms do you see? Look for the plus and minus signs that separate them. You'll see that there are 4 terms, 2x, 3y, -4z, and a +10. So we're just going to write those down with commas in between them to list them. For the coefficients, you look at the terms, which one have variables? They all have variables except the last one. So the numbers in front of those variables would be the coefficients. So we just have 2, 3, and -4. And we just list them with commas in between. 10 is not a coefficient because there is not a variable attached to it. So it is called a constant. Now, if your algebraic expression is not simplified, you cannot identify the terms and coefficients until it is simplified. When I see this one, the first thing I see is that I have the distributive property. So to simplify this, we're going to start by doing that. So I'm going to copy down the 6x, 2y. Now I'm going to do negative 4 times z, which is negative 4z. Negative 4 times a positive 3, which is negative 12. Copy the rest of the problem, negative 3x plus 7. So far, all I did was the distributive property. Now I want to check, are there any like terms that I can combine? I see like terms are terms that have the same variable attached. So I have a 6x and a negative 3x that I can combine. When I combine that, that makes 3x. I have a term without a variable and a term without a variable. I have two constants, so I can combine them. That would be a negative 5. I only have one y term, so I'm going to copy it down. I only have one z term. Now, it doesn't matter the order necessarily that you write the terms down. Normally, we write them in alphabetical order and put the constant at the end. But for this purpose, just simplify it and make sure you've combined all the like terms. Now, I can ask myself, how many terms do I have? If I look up there at the plus and minus signs that separate it, I have a 3x, a negative 5, a 2y, and a negative 4z. So I write those down. We're just doing the same thing. I write those down with a comma between them to list them. For the coefficients, I have 4 terms. One of them does not have a variable. So the coefficients would be the numbers in front of the terms with variables. So I have 3, 2, and negative 4. Again, it doesn't matter if you list them in the correct order, as long as they're all listed. All right, now we're going to look at real-world situations and talk about what the coefficients and the variables and how they have meaning in the real world. Curtis is buying supplies for his school. He buys P, which is an unknown number of packages of crayons at $1.49 per package, and he buys Q, which is an unknown number package of magic markers at $3.49 per package. What does this expression represent? So we're going to break this down. First of all, interpret the meaning of the term 149p. What does the coefficient 149 represent? I have something here, but I'm going to summarize it. I put the term 149p represents the cost for a given number of packages. So 149p, once you know how many packages he bought, you multiply that times 149, and that gives you the total cost. The coefficient, which is $1.49, represents the cost for one package of crayons. If you're writing this in your notes, you may have to pause the video so that you'll have time to write that down. Interpret the meaning of the term 349Q. What does the coefficient 349 represent? Well, 349Q represents the cost of the total number of packages of magic markers that he purchased. And the coefficient represents the cost for one, and the variable Q represents how many packages he purchased. I kind of summarized again what's written there. 349 represents the cost for one. Q represents how many packages he bought. So together, when you multiply the two, that would be the total cost of markers. So the entire algebraic expression, $1.49p plus 349q, what does it represent? It represents the total cost of all of the crayons and all of the markers that he purchased. Again, if you need to pause the video there to write that on your notes. Let's see if we can write some algebraic expressions. Move this out of the way. The number of gallons of water in a tank that already has 300 gallons in it. So you're starting with a tank of water that has 300 gallons. Then, after being filled, you're going to fill it 35 gallons per minute for an unknown number of minutes. So how would we write an algebraic expression for that? Well, we began with 300 gallons of water. Then we're going to add 35 gallons per minute. Can you think about how we would write that as an algebraic expression? We would write 300, which represents what we started with. Then we're going to fill it or add 35 more gallons for an unknown number of minutes. Now, once we know the number of minutes, for example, let's say we did it for 10 minutes, we could fill that into the algebraic expression, and we could figure out how many gallons were now in the tank. But we don't know the number of minutes, so we leave a variable there. Enrique collected 7 more than 2 times as many recyclable bottles that we are going to represent with the variable b as Natasha collected. Write an expression for the number of bottles that he collected. Can you think about how we would write an algebraic expression for this? It said he collected 7, so I write 7, more than, that means adding to, 2 times as many bottles, represented with the variable b as Natasha. 2 times the number of bottles that Natasha had, 2b. We don't know how many bottles she collected, so we represent that with a variable. So this is the expression. Now with the commutative property, you can write 7 plus 2b, or you could write 2b plus 7. They are both correct and will result in the same answer. So today we're just working with algebraic expressions and their meaning and how to write them.